everybody got PV equals nRT. That's the equation. P is what? Take a guess.
Pressure.
P is pressure. V is what? Okay, this is getting into unknown territory. N, R, and then T, take a guess. Temp. Okay, so we've got two new variables, and N would be the number of moles. N is the number of moles. And then R will be our gas constant. And it's something, it's always the same. It's a constant, right? So for us, we'll be solely using atmospheres. Here, let's see, atmospheres and Kelvin. So all your measurement in liters. So all your measurements will have to be in Kelvin, atmospheres, and liters. So this constant is going to be 0.0, another 0, yep, 821. So 0.0821. Mole times Kelvin. And this is the unit for it. Liters times atmospheres divided by moles times Kelvin. No. Might prove useful, but it itself is not the utmost importance. So memorize 0.0821. Memorized, locked in. Okay, so let's do the first problem. I'm going to get rid of. How many moles of Ne are present at STP in a 3-liter balloon?
Quite a few.
So tell me how to do this.
Pressure is 1 atmosphere.
Okay, pressure is 1 ATM. I'm going to do it in a different color. So pressure is 1 ATM. How about volume? So volume is 3 liters. How about N? Do we know it?
No.
No. R?
0.0821.
And then T?
273.
273.
Oh, yeah.
Somebody want to do that for me? Otherwise, I'll grab mine. What'd you get?
0.13.
You got 0.13. Did everybody else get the same answer?
Yeah.
What did I do wrong? Ah, yeah, no, you're right. I did it backwards. I divided this by 3. Yeah, no, you're right. Bad answer. So you got what?
0.13.
0.13. What's the unit?
Moles.
Mole. Cool. Simple enough. Let's take it up one more notch. I'll give you a minute to do it, and then we'll do it together.
And could you show them dimensional analysis too, Mr. Wade?
Sure.
And there's a little note card here for you on the next two problems.
Oh, yes.
Because there are two ways to do this. What Mr. Wagner showed you, the ideal gas law, that always works. So when it's straight up dimensional analysis, okay, STP is your friend. You're always gonna like measuring gases at STP because it's easier, because there's presumptions you can make. It's at 22.4 liters, it's at 1 atmosphere pressure, and 273 degrees Kelvin. The 22.4 comes from,
When you multiply the constant times the temperature.
yep, and you actually divide one side by the other. And if you divide 22.4 by 273, what do you think you get? It's up there on the board. 0.0821. That's where that constant comes from, and that's why it's so important.
We're talking about this, right?
Yes.
Huh?
And yes, that middle one is gonna be tricky because I'm not gonna say anything more. I'm willing to bet someone will make a simple mistake. But what do we say about mistakes? Two things.
Learn from them.
Try to learn from them and try not to repeat them.
You ain't gonna get by the same shit twice, are you? Good.
Yeah, certainly could.
Every time I go in, it comes back home. Come back every year, go back to the same different spot. Very easily.
Getting there? How do you get moles to grams? There you go. You're gonna have to pull out your periodic.
Yeah, we're not pulling these numbers out of the air. It's a known substance.
Yep.
So you can use the periodic table.
Use a periodic table. We've done this a bunch before.
Yeah.
Moles to grams, grams to moles.
This is chapter 3. Yeah.
Yeah.
I don't know. I don't have the answer. I'll have to do it. Remember, what's the oxygen? Yes. But how?
You gotta go moles to grams. 4.5.
You have to have multiple
Here's what we're
Yeah.
And if you're showing your work, there's something that will jump out at you and say, darn it, I forgot this.
There you go. All right, how we coming? Getting there? Still working on that middle one, or have people moved on? Resounding answer. Does anybody happen to be working on the bottom one? No. Okay, still working on the middle one then, I would presume.
Thinking about 9.
Is everybody done with the middle one?
Yeah.
No? All right.
Only in the classroom.
Done with the middle one?
Yes.
Okay, all right. We're doing the middle one then.
We're gonna work.
Walk me through it. There's two ways to do this. Let's do the ideal gas law, I guess. So, somebody help me. Pressure. All right, thank you. Pressure's 1.
Volume is 6.25. Can I grab my water?
Yep.
I'm getting dehydrated, man. I'm getting kind of parched in here. Might have to like this. You?
Okay. What next?
You probably have to put a question mark.
You don't know that. R is what?
You know, point. You could just write 22.41.
I could. And I'll probably start doing that after this one. And then,
273.
yep.
You're gonna need to find your moles. 2K.
Yeah, I noticed. I was thinking
Use
of.
your finger, you'll be right.
No, you guys freak out. Can't handle it.
Busy playing some sports or some
Methane is CO2, right?
Yep. What do we get for the moles?
0.29.
0.29. So N equals 0.29. That's moles. So how many grams of O2?
Yes, do it.
Don't worry, I tell him.
Come on, Jackson.
He gets a little.
You get
He gets smooth, and there's
9.28.
that big man waiting for me in there.
So we got moles, and then every mole
Mr. McKinney,
O2.
Do
we have
you like,
Yeah,
you like
two
a nice
moles.
dunk?
If I have a cup of coffee, yes.
Oh.
See what I'm doing?
Can you do write 2 moles and then write 16 grams? Like I wrote.
No, okay, so think about this. So
It's the same.
for every mole of O2, we have 32 grams. If I were to write every 2 moles on the bottom and 16 on
Oh,
top,
I wrote 2 moles on like top. Like
Oh.
I did 0.29, 2, and 16.
okay, I gotcha.
Is that mistake you were talking about?
Yes, O2. Oh.
If you label your work as you go, you won't make that mistake. Because I'm sure we all have a good work ethic in here, we'd continue to do that, right?
Of course.
Okay, very good.
To get to milliliters to liters, don't you divide by 1,000?
Multiply.
Oh, you're
No, you divide.
These are bigger.
Liters are bigger, so you're gonna have, it's gonna be a smaller number, so you're gonna divide. So everybody get 9.28 grams of O2? Okay, cool. Can I erase these top 2 so I have some working space?
Yeah.
Yes.
Sorry.
Okay.
Were you brewing up any potions?
Yes.
Were you?
Yeah, it was on the hot plate. Yeah.
Okay.
Yeah, that's it.
Makes perfect sense.
Yeah.
Like I was one off
You make a choke good.
because mine was 0.28. So I rounded and I got that.
Yeah, that's what I got too.
What did I put? 9.8?
Yeah, but like when you do it to 0.29, you get what you get.
Okay,
just that
it's
point.
just small, little difference, and it's not that big of. It's just like a rounding thing. I didn't do that equation. I just had somebody tell me the answer for that first half, so that could probably be it. Just rounding. All right, can I erase these top 2 so I have some working space? All right, cool. Okay, tell me when you guys are done.
What's methane?
CH4.
I don't think I did that.
Oh, I forgot to do the. Yeah, that's all right.
But it has to be in liters.
Yep.
How do you get it to liters again? Divide by 1,000? Oh, that's good.
Because if it's not in liters, the R constant is not right. Because the R constants in liters, so that means we have to use liters. It's in atmospheres, so we have to use atmospheres. It's in Kelvin, so we have to use Kelvin. There are other constants out there, but to make it simple where you don't have to memorize a bunch and not know to use what when, make sure it's in liters, atmospheres, Kelvin, or STP.
To get to liters, you
Divide by 1,000.
You only got one.
Is it a pretty small number or what?
I'm not sure. Haven't done it. 1 mole is. Okay, we're going to do this one 2 ways. Everybody done? Getting there? All right, maybe just a little bit more time. Guys getting her done?
I could walk you through this next one.
All right, how about you do that? You want to do it?
I better let you.
Does it have to be in liters?
Yes.
Don't wanna take your job over.
Oh, that's all right.
Gotta divide
I'm
by
okay with it. So we're going to do this one 2 ways as well. Forgot to do it on the last one. You want to do it? Yeah. Go for it. Sure.
Pause that though, Mr. Wagner.
Yeah.
Pause your.
Oh, yeah. Yeah, good call.
Yeah.
All right, continuing the video. If you're watching online, this is the answer. Okay, doing it the other way. Dimensional analysis.
So you're teaching us a way that might not work?
See, I haven't done this way until today, so this is new material for me as well. But it makes sense. So we're going to start off with our given milliliter. And then go liter. 1,000 milliliters per liter. And then we're going to what? What's our end goal? Grams of methane, right? So we start off our volume, convert it into liters, and then we're going to go to moles, go to what our target is. Okay, so what's the number when you multiply the R times the Kelvin at STP? 22.41. And then
I'm sorry, they heard me laughing, Mr. Wagner, because it's just different how I write it. It's just so big, that's all.
oh,
I'm sorry.
Just-
So, it works. It
But-
works.
yep.
It's fine.
I wasn't paying attention. Yeah, good.
They need some learning over there anyway.
There you go. And you guys can do that math. We've done it a million times. So you take 4 times 16, 4.1 times 16,
Divided by 1,000, divided by 22.4.
by 22.
STP always works.
This one over too.
The ideal gas law always works too.
Which one is easier?
You have to decide, am I an ideal gas law person or am I a dimensional analysis person?
You're a dimensional analysis.
Right now, you're doing dimensional analysis. I think it's much easier, but at some point, you will have to use some, whether you use the ideal gas law or not.
Sense, everybody?
Same answer, just different way of doing it.
All right, let's do one more, but it's not going to be in STP.
Wait, where'd you get that?
It's when you multiply. Okay, let's break this down. So we have our volume, and this converts it into liters. So think in your head ideal gas law. So we have our volume. Pressure is going to be 1, so the pressure does not matter, because when you multiply 1 times anything, it's the same thing. So ruling out pressure. So we have our volume, so we got P, V, and then, so let's go 4.10 ml. And then we have 8. Oh, jeez. Oh, there we go. 0.0821 times 273. When you multiply 273 times 0.0821, get this. And so basically, this equation is this. And then, yeah, it's a bunch, but it's that. And then it's built in calculating moles to grams, built into this equation, instead of a two-part equation. That make sense, everybody?
Sure does.
Cool.
It's pushing some time.
All right, let's see how fast we are then. I don't have them.
Yes.
Think we could borrow that radio?
Why for?
I'll make a commercial for Mr. Eads.
Okay.
Infomercial about a radio.
Does somebody have the first problem we did?
Yeah, how many grams of, how many moles of Ne are present
Sent
at STP, but
when we have let's go 2 and liters.
Is that 2.7 or what?
2.7. Uh, 2.1. Okay.
Good job.
Fast line any good?
I don't know.
Said he hasn't played for a couple of years, so probably not.
Said ever since he graduated, it went down.
2 times 2.
Mr. Wagner, are you pretty good back in your crown?
No, I was not.
Ever catch some lobs?
What?
Ever catch some lobs?
No. I couldn't dunk at the time.
Can now, well?
No, I could my freshman year of college. That's the only time I've been able to.
Just go one hand. Typical one hand.
Yeah. Yeah, no, nothing cool. Just enough to get it in there.
Just nothing, something.
All right, you guys ready if I start it? Okay. What? All right, so help me fill this out. Pressure is 2.1.
Volume is 2.7. R is 0.018. I mean 8.
And 280. Everybody catch that? Convert it to Kelvin. What did we get?
You got 0.25.
Yes. That's what I got as well. 0.25. Does this make sense to everybody? And in a worksheet, I could change any of these variables. So keep an eye out for that.
Did you make the worksheet?
I'm sure Mr. McKinney has one, but I haven't looked at it or anything. And we'll probably keep it pretty similar to what he's doing. So, all right. Goodbye.